We want to take a moment and look at the different gas laws that we've been studying. For the gas laws, they involve the variables pressure, volume, and temperature, also the number of moles. So we have two skills that we want to do. First is we want to look at a problem and recognize what kind of problem that is, and then solve that problem. The different gas laws involve these units. Okay, we have pressure of a gas, the volume, the temperature, and the number of moles of gas. Now for all of our problems here, the number of moles is not going to enter into it because we're saying that whatever container of gas we have, we're not adding any gas, we're not removing any gas, there's no leaks, so that kind of stays out of the picture. One law we've had is pressure and volume, and we notice that these two are inversely proportional, so when one goes up, the other goes down. When we have volume and temperature, if you heat up a gas, it gets larger, and if you cool down a gas, it gets smaller. This one here, pressure and temperature, if you heat up a gas, it gets a higher pressure, and if you cool it down, it gets lower pressure. Now these three can all be combined into what we call the combined gas law, and it turns out that's really the only law you have to have in your head, because the other three are special cases. So if the temperature does not change, then it becomes the first law, Boyle's law. If the volume doesn't change, then it becomes the second law, or the third law, Gay-Lussac's law. And in the same way as if the pressure doesn't change, then we're talking about Charles' law. So if you just have this combined gas law in your head, that'll cover most of these different problems. Let's try one. A balloon filled at 99 kilopascals on a day when the air temperature is 19.0 degrees Celsius has a volume of 21 liters. What's the volume of the balloon if it's moved to the top of a mountain where the pressure is only 75 kilopascals and the air temperature is 15 degrees Celsius? First thing to do is to sort out this problem and find out what do we have available to us. If I say I've got 19 degrees Celsius, immediately I'm going to knock that out and change that into Kelvin. So I take that temperature and add 273. So 273, that's almost 20, so it'd be 283. 293 minus 1, 292 Kelvin. Same thing here is 15 degrees. So if I had 273, it'd be 283 plus 5, 288. Now if I don't change those to Kelvin, my answer is going to be wrong. Okay, so this is the temperature, and this is the temperature. Okay, what else do I have? 99 kilopascals, that's a pressure, and 21 liters, that's a volume, and 75 kilopascals, that's also a pressure. And my question is, has a volume, what is the volume? So that's a new V. So I've got two P's, I've got two T's, and I've got two V's, so this must be a P1V1 over T1 equals P2V2 over T2, kind of a problem. So now, let's find our numbers. Okay, so a balloon filled 99 kilopascals. Okay, has a volume of 21 liters. Okay, when the temperature is 292 Kelvin. Okay, now I need the P2. Okay, what is the volume? So this is X. If it's moved to the top of a mountain where the pressure is 75, and the air temperature is 288. Now all I have to do is solve this, and you can see I'm going to cross multiply. So I'm going to have this times this times this, and I'm going to divide by this, and that'll give me my X. So all we have to do is do that. So 99 times 21 times 288 divided by, I haven't given myself enough room, 75 and 292. Okay, I'm going to take a moment and solve that. Okay, when I get all done with that, I get an answer of 27.3, and I was looking for liters, so that's 27.3 liters. So my kilopascals are crossed out, my kelvins are crossed out, all I have left is liters, and that's my answer. So I was using the combined gas law. Now my second of three problems. Okay, a gas in a syringe has a pressure of 750 mmHg, so that's a pressure. At 18 milliliters, that's a volume. What is the pressure of the gas if the syringe is squeezed down to 4 milliliters? Okay, so I can see now I have two P's and two V's, so this must be a P1V1 equals P2V2 problem. And I need to keep track of, which law. This law is the only one that looks like multiplying. It's V over T and it's P over T, but when it's PV it's multiplied together. So this is Boyle's law. So I can see that the 750 and the volume 18 milliliters, those go together. What's my new pressure? Here's my new volume. So let's substitute my numbers. 750, and the units are important. 18 milliliters equals my new pressure and my new volume, 4 milliliters. Okay, so now I just need to solve for my P2, so the answer here is going to be 750 times 18 divided by 4, and I can see my units are canceling out nicely. My answer is going to be millimeters of mercury. So I'm going to take a moment and solve this problem. And coming back, I'm getting an answer here of 3,375. And my units are millimeters of mercury. Now again, I looked at my problem and I found that I had a pressure and I had a volume, I had a new pressure and I had a new volume, so I knew that my law was Boyle's law, P1V1 equals P2V2. Now my last problem, here I have a rigid tank of gas is set at a pressure of 8 atmospheres and a temperature of 18. So before I have a chance to forget, I'm going to add 273. So 273 plus 20 would be 293. So this is 291. The tank car can withstand a pressure of 25. So I'll put a P over here for my 25. And how hot can the tank be heated before it begins to leak? So I'm looking for a new temperature. So I have two pressures and two temperatures. So I can see my law is going to be P1 over T1 equals P2 over T2. And one thing I notice now is that one of these is atmospheres. No, they're both atmospheres. We're good. So we have 2 atmospheres, we have 2 kelvins, so we're just going to substitute. Okay, pressure 1, 8 atmospheres at 291 Kelvin is 25 atmospheres over X. I'm trying to find my new temperature. So now all I have to do is cross multiply. So I can see I'm going to have 291 times 25 equals 8 times X and X is going to be my new temperature. And I just divide both sides by 8. And atmospheres are crossed out. My answer is going to be in Kelvin. I'm going to take a moment and solve this problem. For this problem, I get an answer of 909.375, and this is Kelvin. Now, if I want to give it back in Celsius, I subtract 273, and I get 636.375 degrees Celsius. And I would round that off to say 909 Kelvin and 363 Celsius. So each of these problems, I've gone through and look at my numbers and decide, is it a pressure, or is it a temperature, or is it a volume? And if it's a temperature, be sure and change it to Kelvin so I can get the right answer. So I had problem 3, I had problem 2, I had problem 1. And the idea here is learn your laws. They will be there on the test for you. And again, this last law is the only one you really have to know. But notice that P times V, but it's V over T and P over T and PV over T. So learn the shape of the laws and you'll be okay.